Hello, hello. Yeah, a new day, a new stream. Today we'll start with solving the problem of the day. So some updates on the stream. Added some free royalty music. As well, I have my cup of coffee, or it's actually not coffee, it's a tea. So I have my cup of tea. Yeah, checking the quality of the stream. So I have my cup here with Mickey Mouse. So I didn't see the subscription, so probably I should try to find myself. Yeah, I'm marked as live. Cool. Okay. So I think we are ready. We'll start today with the problem of the day, which is a house robber. I managed to read it, and the idea here, you're a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security system connected and will automatically contact the police. If two adjacent houses were broken into one on the same night, given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. So if I understood correctly, if we rob house 1, we will not allow to rob house 2, so we'll need to go into house 3. So that's the constraint in our case. Yeah, let's go on the drawing board and we'll try to define our solutions. So I'll need these two examples. So let me add it here. Okay, I think like this will be good. So we have the assumption. So let's start first with this one. Actually, it will be like this. So we have our values here. Let's assume we have like 1, 2, 3, and 1. So first idea, it's like we'll need to find all combinations. If we're talking usually about a dynamic programming problem, the trouble is often we need to decide to include something or not. So our algorithm will be to include 1 or not. So we can have two possibilities. So our branch tree will start like, if we include 1, then we'll need to go to free the next house. We're not allowed to go to the adjacent one, so we'll need to skip 2. So we'll have this solution, 1 and then 3. But if you are not including 1, then we can start at 2. So if we get to 2, then we'll need to go to the last one, to 1. So probably I'll need an example which is a little bit bigger with more houses, so that will be easier. Because my initial idea was, why shouldn't I go greedy in the form of, so I have like 2 possible for loops. One, we start with the first, and then the second will start here. So for the first one, because I've checked the constraints. So if we look at the constraints, we know that we'll have a positive amount of money. So it's not possible to have like negative. Yeah, it's not logical though, in the context of the problem. But as well, it's not logical. It's not possible. Okay. So in this case, I was thinking to go, why shouldn't I start with the 2 for loops and see in the end which one is bigger? But this has an interesting twist to it. So let's assume we have another example. So let's start with this one. So probably this one will not be exactly what my point here. But we may have like, let's see. So we have 2, 7, 9, 3, 1. Because here I think it's also, we start with this. And then we go to 9 and 1, or it's we start with 7 and go to 3. So the solution here, it will be like 12, or the first path. The first path, which I mean this one. But if you check another example, I want to get to an example where, for example, we have like a 2, 3, and then we have like a 9, 6, 7, 8, 10, a couple of big numbers, and then 2 and 1. Because if we start like at 2, then we may go to 9, which is a big number. But then, instead of going to 7, we can skip both of these two, like 6 and 7, and go directly to 8. Or even not like that. Yeah, probably it's not the best scenario, but it is a possibility due to constraints that we may skip. So instead of like 6, 7 here, to have like 2 and 3, so some small numbers, and then I want to skip both of them, to not go into 9 and 3 right away, but to skip both and go to 8, because 8 is bigger. So, so yeah, that's my thoughts. Okay, so probably now we'll need to try to code this. And our solution will be something on those lines. So we will need the following cases. If, for example, we got to the last or out of bounds. So if it's the last or out of bounds, I guess if it's last, we'll need to get the value. So we'll return the value from our vector. If it's out of bounds, we'll insert a very big number. So we can do an I32, actually not a very big, but a very small number, to not get into troubles. But for the other cases, we'll have two options. Either include our recursion, so if you call this a recursion of n, we'll either include the recursion, we'll provide a j or an index for our vector, or we'll do, yeah, so we'll go j plus 1 to the next one if we don't include. So this will be like we don't include current. We don't include. Or if we need to include, will be like the sum of current which will be vec of j plus recursion, but in this case will be recursion of j plus 2, because we need to skip the next one. And we'll need to find the max out of these two, and that will be the result. So that will be the thing which we'll need to code. So let's try to go in this direction and code it. Yeah, let me create now a problem. So house robber, cargo, new, lib, house robber, cd house robber. We'll not need this. We'll use this one. Yeah, let me edit, zoom it a little bit. Add my interface, which we'll need to code now. This will change. I'll be changing this one, so let's test solution. Okay. Let's add a couple of scenarios. So scenario will be vector, and we have an output. But now we'll work like this. So we've got solution, and we need, yeah, this will not work, as we need to define our struct solution. And let me add a to-do here. Rob. So this will be a definition, and let's create our scenarios now. So first scenario will be this one. Expected result to be 4. Next one will be this one. Expected result to be 12. Let me try to run it. Yeah. So everything looks good up till now. Yeah, streams, it's shown as healthy, which is really good. So checking streams, checking comments, if everyone joined. Sipping some tea and thinking on how we can solve this. So usually for this type of problems, we will create a recursive function. We can call it a DFS or DP, probably DFS. So usually people call it as DFS, where we'll have an index. So we'll monitor this index. It will be like index of the element to include. What else? We'll have like our nums, which will be a reference of our vector. And we'll have our result. And then we'll need to code our base scenarios. So most of the time for this type of problems, we will need to add the memoization. But at first, we don't really need it. So I'll code it without memoization, and then we'll add it. So I guess first stage we'll need to check if it's the last or out of bounds. If it's last or out of bounds, so how can we do that? If it's last, we can write it in the form of if I will be equal nums of len minus 1, then we'll just returning nums of I. So let's return that. The other case will be if I will be greater than nums of len, greater or equal. Then we'll return a very big number. Yeah, probably I should use a very small number. We can use the constraints. So 100 numbers and the values from 0 to 400. So I guess we can use like, we can create a const min of an I32, like minus 10k. Or if minus 400k. Let's go like this. So we'll be returning this min value. If we're out of bounds, we need to return it. Otherwise, we may get into some small troubles. Then next stage will be to identify, because we are doing a max function. Our goal is to maximize our value of the rubbed houses. So we, in this case, will have like two possibilities. So first possibility will be, as we identify, to include something. And if we include the current house, this will be something on those lines, something like let result will be this thing. So it will be like I32 max from two options. First option here I'll be writing in the form of yeah, let me write it like this. So we need to include how actually we do this inclusion. So we'll do like nums of I plus we'll go with our recursive approach, but we'll start at I plus 2 because we need to skip one house. We cannot go to the next one, so we'll skip this one and we'll go to the next. But at the same time, we may not include this one. And then our goal will be to just go to the next one in nums. So we'll need to find the max out of these two recursions and return it. So we'll be returning our result. If I'm not mistaken, this should be it. So we can call this a dp. We start at the position 0 and we pass nums as a reference. So let's see, will this work, or we need to do some optimizations? Actually, it did not. Yeah, let's check why. Because we've got like 3, but it should have been 4. Yeah, probably we have some bugs here with our base case scenarios. Yeah, but let's try to see. Okay, so I will be 0, and then nums len minus 1. Okay, if it's not the last, it's not greater, then we'll do this. So nums of I will be 1, and we try to include I plus 2 or 3. So if we go here, Yeah, probably this is the case, because if we go out of bounds, probably we should not include it. We need to return 0 in this case. We don't need to go with, yeah, I think that will be the fix. Yeah, okay, so that was our bug. So now it's kind of solved. Though we have a couple of troubles. If we try this solution now, yeah, we will not need this one. If we will try this solution on LeetCode, it may not finish. So yeah, first thing I guess, let me try to run it on LeetCode. And then next stage we'll try to add memoization to optimize it. Yeah, you see we have this issue with the time limit exceeded. And in order to fix this, we'll add memoization, because some of the solution will repeat, so we'll need to go only once in depth. So this is called like a top-down optimization. So if they repeat, then we will stash the results in memory, and this will improve the performance. At least it should. So how to do that? We'll be creating a memory or a memo. I'll call it a memo, a mutable memo, which will be a hash map. And then we'll be passing this memo as first argument. So memo here. And then at this stage, we'll need to add it. It will be like memo, which will be a mutable hash map of an usize, because the entry point will be I, and the result will be an I32. And yeah, we'll need to pass this memo. Yeah, we don't need to do it like this. We'll need to pass this memo everywhere now. Yeah, I still want this to be in 2 lines, but probably it will not allow because this it's a bit short. So yeah, first stage in this case we'll need to check if we have a result in our set. So if let some result will be equal memo get I, so our index. We'll try to get the result in our index. If it's there, we'll just return the result. But we need to add the result as well. So to add the result, we'll do it here. We'll do like a memo insert. Key in our case will be I, and the value will be result. So this is technique. It's called memoization. It's extremely common in DP problem solving. So there are two main methods for DP problems. Is either tabulation, which is also called like bottom up, or memoization, which will be like top down approach. In this case, we choose a top down approach. Not necessarily sure that that's better or worse than a top down approach. But hopefully this will be good enough for us to finish this example. Okay. Yeah, I'm not sure what will be the result here. So let's try to check. I'll put 15 at first, but let's see if this will finish. So yeah, probably that was the result, but it didn't finish. So let's check with the memoization if this helped. We'll need to remove this line. Yeah, as you can see now, our solution is accepted and it's correct actually. So let me update my test cases for this to work well. I'm not sure what happened with my laptop. Just close the screen. Yeah, so this works. And yeah, let's try to submit this and see will we get a result. Awesome. Cool. So we solved the problem of the day. So it's a DP problem. Hopefully you got the idea how to solve it. So DP problems are a little bit more complex. So it's an advanced skill, but this one I could consider it as an easy. So the constraint was not super difficult to add. And the good news is that I started to consistently solve DP problems, which before I mean, last year I had huge troubles trying to solve them. So that's a good news. But there is another problem here now. I rarely use the tabulation method. So I'm pretty confident in my skills with memoization. But with tabulation, I do not use it as often. Yeah, let me check what's going on with my laptop. I'll do a restart. So hopefully this will work. Yeah, technology nowadays, pretty weird. Cool. We solved the problem of the day. Yeah, let's get back to our problems in our easier category. So we solved like the medium one. But let's get back to the easy stuff, which sometimes is not as easy as it should be, or as we want it to be. Yeah, so first page we're done. Reduce transformation. I think yeah. Last time we had huge troubles with this one. We wanted to make it optimal, to do some optimization there, but it was a nemesis for us. Yeah, I'm checking. Okay, let me connect back to my stream. Okay. Yeah. Yeah, I would like to restore my session. Okay, cool. Let's get back to problem solving. Okay, so array reduced transformation. That's a JavaScript one. but maybe it's a fast one and I want to just get rid of it. Given an integer array nums, a reducer function fn and the initial value init, return the final result by executing the fn function on each. Okay, so let's do this. Return nums dot reduce. I kind of forgot the reduce syntaxes because it's a little bit different than Rust, but I think it's first will be like fn and then will be the init, and that should do it. I think init it's the last argument, not the first. Yeah, okay, cool. So solve this one as well. Let's go on. How about this one? Sum of all odd length subarrays. Yeah. Sum of all odd length subarrays. Given an array of positive integers R, return the sum of all possible odd length subarrays of R. Okay, that's an interesting one. Because, yeah, at least the constraints are small. So in this case, could you solve this problem in O of n time complexity? Yeah, this is another dynamic programming problem. Because we need to do combinatorics. The idea here, it's like the big sum, like this sum contains already the sum of this, and I guess other small sums. Output 66. So for 1, 2. Wait a second. Given an array of positive integers array returns the sum of all possible odd length subarrays. So odd length will be like 1, 3s, 5s, and so on. So a brute force solution. So let's think of, yeah, this is a scary one. If I would have received this, this one at an interview, for sure, it's not super easy, though I'm a little bit astonished on the acceptance rate. Because a solution may be like something in the form of for I to get like all possibilities. So we'll start at I in 0 to array length. So we'll get like values of in the form of if I modulo 2 equal 1, or it's not equal 0. Yeah, that would be a more correct one. And then we'll do 4 loops of doing combination of how many items, like 2, 3, 4. But like here, I guess should be a trick or something. You can brute force try every ij pair, and if the length is odd, go through and add the sum of the answer. Yeah. That would be like a brute force approach. But if you want to do it in O of n, we will need a DP approach. Because we'll need to add memoization again. And now let's think how can we do that. Let's think on how can we do this. Yeah, if follow up, could you solve this problem in O of n time complexity? I'm thinking. All possibilities. Let me see. Subarrays. Okay, so if we're talking about subarrays, they need to be adjacent. So it's not, or should they be adjacent? So it's 142 and 425. I have a deja vu, like I've checked this problem somewhat in the last some of the last problems which we solved was similar to this one, but I've already forgot what was the solution there. So what did we do there? I don't remember. It was a medium. Yeah, let me check my latest medium problems, because I think I solved something similar. Okay, let me commit this one. The problem of the day. So we are January 21. Rob houses or something. And then let's check edit the problem of the day. So what was the problem of the day? Minimum falling path. Was this sum of subarray minimum? I think that was the trick. Okay, let me try to find it. Code sum of subarray minimum. Did I solve this one? Oh, I recall. Yeah. This one was expected. Yeah, this one was a hard problem. Yeah, and it was expecting us to look into this, how it's called, a special data structure called stacks, like monotonic stacks. So we were looking, we needed to check like monotonic stacks, and I have trouble solving it. So this one I didn't solve, but I've looked into a similar thing. So yeah, okay. We didn't solve that one, but we'll need to solve this one. IJ. Okay. Yeah, let's try to go on the whiteboard and think of a solution. Maybe we'll find something pretty cool. So our goal is to solve it in time complexity of O of n. For sure, we'll need to expand memory to solve this one, but we'll need to check first, is it possible though? If yes, how can we do it in O of n? So yeah, if we upgrade to O of n, then our problem becomes a medium, at least medium. Yeah, let me copy scenarios here. Examples, I just need one. Let me use a new canvas. Yeah, I guess that should be good enough. So let's get back here. So we have like the following numbers: 1, 4, 2, 5, 3. So we'll need to find subarrays of odd length, all of them. So let's try to identify possibilities. That's an odd number, so 1. We may have like 4. Yeah, so if we talk about this, so 2, 5, and 3. So that will be all subarrays of length 1. So I guess that will be one of the base scenarios for our solution. The next stage is to build subarrays of another odd size, and the next one will be like len 3. So for len 3, how many do we have? We have like we start like 1, 4, 2. The next one will be like 4, 2, 5. And then we'll have the third one will be like 2, 5, 3. So we have 3 of them. And the last one will be array of size 5. So we have only 1. It will be like 1, 1, 4. You might use a 2-pointer approach. Oh, interesting. Hello, hello, hello. I didn't notice your. So sorry for late answering. Yeah, I have some experience with 2-pointers, though I'm trying to think how exactly this works, because I do not have this in my arsenal of tools. So we can try to brainstorm. So 2-pointers will mean like a window slicing approach or something. So something like this. Yeah, let me try to go. So if I have this, so like 1, 2, wait, write it. 1, 4, 2, 5, and 3. So we'll start at I and J here, and we expand in the form of so we start here, this will be like our sum, total sum. So sum I and J, it's at 0. Then we go to the max, we increase J like at 2. And then J will be at 3. And we go till next. And once we got to the max, then we will increase I and J to 4. That's the approach of 2-pointers. Machine learning developer. Oh, hello, Dennis. Dennis, do I think it's worth learning Rust? I think if you know Python as an upgrade, yeah, I think so. Yeah, okay, yeah, that's actually a very nice idea. Yeah, thank you, Chian. Sorry if I butcher your name, Chayan. But that's a good approach. I still don't think that will be of n, because we'll need to dangle with this j. So we'll still go, I will be like incremented n times, but j will be incremented like n, I guess, divided by 2 or something like this. So somewhat still n square. But a good approach, I guess, for starter. Yeah. Okay, so then it's about your question. About the question learning Rust for machine learning engineers. So Rust is way faster than Python. That's incomparable. Though Python still has an ecosystem way stronger and bigger than Rust at the moment. So for a machine learning, if you are super good with Python, you know all the libraries. I'm not very deep into machine learning, but still I will go with Python first, and then it will be more like an optimization to once I got, I created my models and stuff. If I want to make them even more optimal, where I want to make them faster, then in this case I would go with the Rust. But most of the libraries which I know, they're still using Python in the background. They create like the models, but they call in their backend applications, they execute those models on top of Rust. So Rust is very good language, very strong. But as a starter, still Python is by far orders of magnitude more useful and helpful at the moment. It has a huge ecosystem, incomparable with what Rust have. Okay. Yeah, should we code like chain solution? Because I kind of like it. I kind of like it with 2 pointers approach. I do not know how to make it linear though. I'm thinking, how can I make it linear? So 2 pointers. Okay, so we have an algorithm, and I think it will work. But with this one, so we found this. 1, 4, 2. I'm thinking, how can we solve this problem from already solved problems? Because for example, we have this part which is repeating, but at the same time we have parts which are not repeating, like this. So yeah, I don't know. I don't know if that's possible to solve in O of n at my current level of energy and expertise. So probably we'll just go with the 2 pointer solution for now, at least. Will this include? But let me think if this will work in all cases. So, because it's not obvious. If you go with this I and J approach, we increase J. So we'll got J here, but still we'll need to sum everything. So yeah, it's even worse than n square. I think it's even worse than that. Because we will do something like this, I and J. So J will increase the pace, and we'll have a subarray like starting at 0 and J like being 2. And then we'll have a subarray like 0 and 4. Yeah. Actually, first one will be 0. This size, and then by 4, and then we'll have the same with 1s. 1 and 3, and then 1 and 5, and then 1 and 7, and so on. So how many of those we'll have? A ton. Yeah. I don't know, guys. That's a difficult problem for me to solve in offhand in a linear time. Yeah, how can we do this? Because I really want to solve this in linear time. Yeah, let's try a different approach. So I guess a base case scenario will be this. Then how about those? And then what will be the next one? So the size. Because what's the subproblem of this one? So 2, 5, and 3. So we've got to this stage. So let's say the subproblem 1, 4, and 2. That will be, so let's get this subarray. So the subproblem of this one will be like 1, 4, and 2. and then will be like 1, 4, and 4, 2. Oh, so we have paths like this. So we do have paths like this. You see, a good thing is if we go with like a recursive approach, any path of this two, it's already solved. So for example, this one, not this one, but I guess, yeah, big one. If we solve everything, sooner or later we'll still get... Yeah, but this is not odd, so we'll not have it. Oh my god, what am I doing? Yeah, you're right. It may take up to 2.n. So we'll use a memoization technique. Because let's say 142. So we'll have a repeating subsolution. So this one. So I was thinking of doing a memoization to reduce the time. Yeah, but the trick is in this case we'll need to do like counting. I thought I had something. We'll need to do like pretty much all combinations of sums in order for this to work. Because my goal, it's I want to do some sort of divide and conquer algorithm where I want to find the sum of this one. So this one, we see that this part, it's already repeating. So once we solve this, we can cache it. So add it in memory. And this, so for example, what will be like the result? It will be like 10. And this part, it's also repeating. It's repeating in 142, like here. So we can cache this one as well. So if we cache this and this, it will not be like 2n at the power 10, but it may go to a linear approach because we cache it a ton. So we'll not divide and conquer a lot. But how can we do this? That's the trouble, because I do not know. Okay, so to keep it simple for now, I'll just code 2 pointers approach, because we see here it's the constraints are not very big, so we have like 100 items in our array, and then probably we'll just we will be good enough with some sort of brute forcing ij pair. Okay, so yeah, let me try to code this stuff. So we'll have a sum. Yeah, by the way, guys, I didn't check. Do you hear the music in the background? Is there any music? Like some sort of chill music? Nothing super... So some chill out music. relaxing. Okay, so I've got my pointers, and now let's code this. Exactly, yeah, that was. So do you think it's the volume? It's good enough, or should I increase it or decrease it? Because I don't really want this to overpower my voice, at the same time to not be like very intrusive, but more like to be more relaxing. Yeah, let me do it like this. Good enough. Awesome. Yeah. Awesome. That's really good. Okay, so let's try to type it. So we will have this. I kind of forgot already what was our algorithm. I guess up till I it's less than len. Yeah, less. We will need to do small sums. So j will start at I. I guess we can do it like this. So j will be equal I. While j will be less than len. We'll do j plus equal 2. Yeah, let me think. Is it right though? Should we increase j plus 2? Yeah, so assuming I it's and here we'll do like I plus 1 and j plus 2. So if we'll have like I being 2, index of I being 2, yeah, it's good. So we have this, and then we'll need to have our sums. So our sums will be yeah, here we may have troubles with boundaries, but here we'll have like array of ij. We can do iterator and sum. So yeah, this is not even actually we need to do it with equal. It's not even and square. I think it could be worse. Yeah, it could be like an cube or something. Because worst case scenario here we'll do ij, and then for smaller j's we'll do like smaller ones. So we'll need to return some. Yeah, I have a feeling this will need to be debugged because I may have some bugs here and there with out of bounds. So let me copy this and go here and create fastly a VS Code example. Sum of all odd length subarrays. Cargo new lib sum of odd length subarrays. Let's go inside. I will not need this anymore. I'll use this. So let's add the tests. Actually, I think I should have left the example, just paste this part. So struct solution. Yeah, this will need to type what exactly will be the type of this one. Yeah, so scenarios, not here. The solution. Okay. Scenarios. Let's add a couple of scenarios. So it's 58, if I'm not mistaken. What's the trouble? Oh yeah, I have a typo here. Okay, cool. So here we'll do like solution of sum of odd subarrays, odd length subarrays, and if we do this, we had some issues like yeah, range and index 7 out of range of our slides of length 5. Yeah, this is what I'm talking. Yeah, so a solution for this one will be to move it. So we start by doing this first, and then we'll increase it. Because if will be smaller than len, that one will exit right away. So let's run this test, and this worked. So cool. Yeah, let's add a couple more. Yeah, Rust, it's not an easy language to get into. But it's powerful. So it has a very powerful compiler. So it will help you find tons of bugs. And you'll need to learn how to write code in a Rust specific way. As it's I have a background in mostly in like scripting languages, Python, PHP, JavaScript. So once I got into Rust, I was astonished as how difficult it is for me to understand why I cannot do like simple stuff. Why I cannot pass a reference here, or why this is not allowed to do. A function cannot like return a variable created inside that function because it has this concept of lifetimes. But once you get used to this, you'll write very solid code, and it will be with less bugs. But it's not easy, so you'll need to put the effort into learning it at first. So yeah, let's add a couple of other scenarios, like this 2, 1, 2. So like 1 and 2, and the result will be 3, and we have another one like 10, 11, 12. 10, 11. Okay, so this will be like 10, 11, and 12, and the output will be 66. So let's add this. Yeah, scenarios work. I hope the solution will pass on time limits, because if it will not do it, if it will not pass on time limits, then we are stuck for the rest of the night with this one. Yeah, I really thought on a way on how we can solve it in linear time with memoization, but yeah, I'll need to think off stream. Okay, so looks like there is a solution. Maybe it's arrayify. So this guy uses some math. Oh, Oh. So yeah, that would be a linear solution. So let's try to understand all. What exactly is he doing? Because he does a math thing. Plus 1 multiplied by len minus I plus 1 divided by 2. So I feel like this is a progression or something. Yeah, this feels like a progression. Yeah, let's try to write this into our whiteboard. I really like to know this. Because this feels very cool. Yeah, what we wrote, it's... How can we put it? It's working. For small cases like this, it will work just fine. But it's not like an optimal solution by far. Yeah, let's use a new canvas. Yeah, I'll need to go back. Yeah, let's take this screenshot and let's try to analyze this and see what's the cool part about it. So what does he do? So he has like this sum and he sums it. So we have our item in the array, where our number, and then he multiplies this by the position of the number. Okay, so it will be like I plus 1. And multiplies this by len minus I. Len minus I, and this will be plus 1. And everything divided by 2. And how did he get to this? I feel like this is this solution is not an intuitive solution for me. It's so difficult for me to understand. I thought calculating pre-sum and check the ranges of O n multiplied by n. Which one do you mean? The one which it's linear? This one? Or the stuff which I wrote? Because the stuff which I wrote, it's with the two-pointer approach. Because this is just a progression. You know this thing like the sum of all numbers from 1 till x till n will be like 1 plus n multiplied by the sum of how many they are. So how many they are, it's like n multiplied by n divided by 2. So if you go like 1, 2, 3, 4, 5, the sum of all those elements will be like this will be like 6 multiplied by how many pairs we have. No, how many numbers we have. So we have like 5 numbers and divided by 2. So this will be like 30 divided by 2, 15. Something like that, I think. So yeah, that's 15. So yeah, n multiplied by n plus 1 divided by 2. Exactly. And I think his formula is just this one. But he so he just applied the math formula. Yeah. Instead of doing like n multiplied by n plus 1 divided by 2, he did the number and how many times it's repeating in different scenarios. So for example, if we go with this, let's go with an example and try to understand it. 1, 2, 4, 5, and 6. Let's go with this. So if we go with 1, how many times we'll see 1? It will be like when it's single, when it's in 1, 2, 4, and when it's in 1, 2, 4, 5, and 6. So it's 3 times. So on his formula, he writes if it's the first, it will be like 1 time here. Len minus I will be like 5 times plus 1 will be like 6. And divided by 2 will be like 3. So exactly that's his solution. So he identified a way using a formula on how to sum this element the right amount of times. So yeah, that's really cool. Yeah, I did not think of going this approach. I was going with the memoization, but that would not produce any good results for us. So yeah, sometimes like math can help us to identify a solution like this. So yeah, for sure it's not like intuitive, because we backend engineers, we're engineers, we think differently. We do manipulation on data structures, so math it's alienated for us. So math for us it's a last resort. So people like competitive programmers, yeah, they have like a keen eye for this kind of problems. They look at this and see right away. And I guess this comes through experience. But for backend engineers or front-end engineers, where they create apps, we never use this kind of stuff. So it's not something we are accustomed to. So it's not intuitive for us to think in this direction. So this is what I think. But yeah, that's a really cool approach. He figured out a way to create a progression and sum this number the right amount of times. Okay, so we got like more normal solution, still working, but not the fastest for sure. Yeah, let's move on. I think I'll be up a couple of more problems, hopefully. So yeah, pretty interesting problems though lately. Minimum bit flips to convert number. Hello, Bay. How are you doing? I assume you are Armenian or Georgian, Bay? Your surname seems like a Georgian or Armenian. So how is the weather? So where are you from? Yeah, good. Nice that you joined here. So welcome aboard. So we are doing LeetCode problems in Rust, Turkey. Yeah, okay. Yeah, probably yes. Sorry, I mistaken your surname. I thought it's has roots into Georgia or Armenia. Weather is nice. Yeah, pretty cool. Yeah, I know Turkey. It's a pretty hot country. I used to visit it during summer. My wife loves like all inclusive in Turkey. So you have some very nice hotels there, which I enjoy being. Cool. Yeah, so I'm talking that we are trying to solve problems. Did you ever try the Neat application? with Rust, neat application with Rust. I'm not sure I know what neat is. Let's see. Neat. No, I don't know what neat is. Yeah. If you can elaborate a little bit on what neat is. Neat, no, meeting space the neat way. Yeah. Non-exercise activity thermogenesis. Unlikely it's this. So maybe neat.no. Download. Sorry, neat is an algorithm. I mean evolutionary AI. Oh, no. I'm a backend engineer, so I tried in Rust to create some neural networks. So this is what I've tried, like basic stuff with just a couple of layers, not that many neurons. So I was looking into the math. Okay, so neuroevolution of augmented topologies. No, I never tried that, so that's a new thing for me. So ML, I think there was another ML engineer here. So it was Dennis. So you may speak with him or connect with him, because he asked another question about using Rust as a in ML, and I've told like I would suggest you still go with Python at first. Yeah. The things in Rust, I think there is burn, which I'm not sure if this will help you a lot, but let's try to see. Burn arrays. Yeah, so it's not sure if that's what you're searching for, but a promising library is this one. So it's a deep learning framework. Maybe it's not the same thing which you are searching, because I'm not very deep into machine learning or deep learning or evolutionary AI stuff. But that's a promising thing. So I think during a stream, we'll try to create an app using this library. So you may look into this one as a, maybe it has something useful for you. So it's called the burn arrays. Yeah, let me try to type it. Okay, yeah, let's get back to trying to solve our problem. A bit flip of a number x is choosing a bit in the binary representation of x and flipping it from either 0 to 1 or 1 to 0. For example, for x equals 7, the binary representation is 1, 1, 1. And we may choose any bit, including any leading zeros not shown, and flip it. We can flip the first bit from the right to get 1, 1, 0, flip the second bit from the right to get 1, 0, 1, flip the fifth bit 1, 0, 1, 1, 1. So given two integers starts and goal, Return the minimum number of bit flips to convert start to goal. Interesting one. So how many bit flips we'll need to do to convert start to finish? So we've got like 1 0 1 0, and so this will be the starting point. So 3 bits. Yeah, I feel like this is another kind of math problem. So flip the first bit from the right. Okay. Flip the third bit from the right. Okay. Flip the fourth bit from the right. Okay. It can be shown, we can from 3 steps. Yeah, trying to think. Yeah, let's see some hints. If the value of a bit in start and goal differ, then we need to flip that bit. Yeah, kind of that's correct. Consider using the XOR operation to determine which bits needs a bit flip. Okay. So yeah, we'll need to check a couple of examples for this one. Another easy problem, though I have a feeling we'll spend some time here because I have a blank in my head on how to solve it. When I hear problems with bits, I get a little bit of insecurities, let's put it this way. But should not be an issue for us. Yeah, let's go with a couple of examples on our whiteboard, and then we'll try to identify the algorithm. So let me do a screenshot. I just want to have it. So we've got to this state. So yeah, 10. So 10 will have a binary representation of 1, 10, 1, 10, and then 7 will be like 0, 1, 1, 1. But the trouble is, first we'll need to have this structure, I think. Because we'll need to change this bit. Yeah, we'll need to transform it in 0, so it'll be a switch. Then this bit will need to become 1, and this bit will need to become, it will remain the same, and this bit will be switched again. So yeah, let me put this, will be like switch, switch, remaining the same, and switch, and switch. So we'll have how many switches? 1, 2, and 3. So we'll have like 3 switches. So I'm thinking of a way like I can transform our 2 numbers in a binary string. So have it as a string. So for both of them with chars. Like 0, 1, 1 and 1. I can zip first and second, so I can zip the first one to be like 1, 0, 1, and 0. I can zip these two and then count how many of those are different. So this should kind of work. I think that could be a solution. Though the trouble is with leading zeros, because I'm not sure this will do the trick. Two power x minus 1. So x, you can write. Okay, Tuhin Gosh. Hello, Tuhin or Tahin. I'm not sure if I'm pronouncing your name correctly. So yeah, let's try first to understand. You can write with every int number as 2 multiplied 2 power x minus 1. So what exactly do you mean? So if, for example, if 2 power x minus 1, so if I put here 1, 2 power 1, it will be 1. So for 2 power 2 minus 1, it will be 3. Okay, so what's the idea? 10 is 2 power 3 plus 0 x plus 1 x 2 power 2 plus 0 2 power 1 plus... Oh! You mean the number of bits stuff? Yeah, that's a way. That's a way. I kind of 10, it will be 2 power 3 plus 0 x. Yeah, I'm not sure if we need to go this deep, because I still plan to go into formatting them as binaries and just count this stuff. So that would be like a backend engineer on how to treat this problem. so yeah, I feel like yeah, let me check. I'm not sure I got it. So 2 power 3 plus 0 multiplied by 2 power 2. Yeah, I mean that would be the formula of bits, but not sure how this will help me. Because if I want to transform any number into bits, I guess I can just do division by 2 and modulo 2. So old ways of transforming a number into bits. But do we need that? That's the idea. I need just to check a thing. So yeah, let me check a simple thing. Test binary rep. Okay. So for example, let num will be 10, and I want to print line. I think I can do it with b. How can I do this? I kind of forgot. I think it's like this in a binary form. Yeah, there is a representation in Rust of this numbers in binary, but okay, so probably like that. So it will be this 1 0 1. So I already have the binary representation, but I want to check with 7. Let 7 will be 7, and let's do this and for 7. Yeah, this is the trick though, because I'll need to add the leading zeros, Because if first is bigger than the second, I'll need to add the leading zeros. So probably our algorithm will be something like, yeah, let's check the constraints, because I guess the constraints are, okay, so with 0 and 10 power 9. 10 power 9, it's a pretty big number though. So yeah, I guess the simplest way is to equalize them. But yeah, how can we do this in an optimal, fast way? Thinking on how can we do this. Because I'll need to write something like that, which I don't really like. If, for example, binary wrap of first, it's len, it's greater than binary wrap of second dot len, then we'll need to add leading zeros for second to equalize the lens. Oh, wait a minute. No, we need to do that. Else, if second part, then we need to, yeah, I guess it will be an if else solution. So yeah, let's try to code this. Yeah. I think I wrote exactly this approach. So so if you look at this example, I want to find binary representation and then compare expressions and how many are different and count them. So this is actually what I'm trying to code now. But we need to solve first the leading zeros problem, because I need to have like two equal binary representations. I think what your suggestion, it's exactly what I'm trying to implement now. so let's try to see this. So yeah, let me try to create a function. You know, fn how many changes, wherever. So we have first, which will be in I32, I guess, and second. We start and what did I call it? Okay, so min bit flips, wherever. Let's call this. Okay, so we go like best min flips. Okay, so we'll have this. Let's set a couple of scenarios. I have start being 10 and goal being 7, so we'll need 3-bit flips. Start and goal. Yeah, looks like I have a typo somewhere. Like too many of those. Yeah, what's the trouble? Yeah, let me do it like once again, like scenarios. Because this will be a little bit easier. I have trouble here. So here will be like start and goal. And here we'll have start and goal. Okay, so we have our example. So first thing we'll need to do, transform it into binary form. So let binary start will be format, and we'll do this b and start. And then we have like a binary goal. So we have two strings at the moment. And now what we want to do, it's add leading. So yeah, let me write a 2D here for this to compile. So we have two strings. Now we'll need to make them equal size. Because if we don't do this, we'll have a little bit of troubles. So I guess if binary goal.len is greater than binary goal binary start.len, add leading zeros for binary start, else add leading zeros for binary goal. If they're equal, we don't care. Yeah, this is else. So yeah, we'll need to make them both mutable in this case. So the assumption that binary goal is greater than binary start len, let size will be binary goal.len, and then we'll check how many leading zeros will be size minus binary start.len, and then we'll do what should we do here? I guess maybe like this. I think there is we can do like a binary. What we need to update? Binary start. Okay, so binary start will be format. Yeah, it's a lot of operation, which is a little bit ugly, and we'll do like a 0, repeat leading zeros, and we'll have binary start. So it's something like this. And we'll need to do similar stuff for the second, but in this case it will be like binary start, and here it will be like binary goal. It will be the binary goal here, and this will be binary goal. So we have this. Probably we can extract this into a function, and I think this is what I will do as an optimization. Yeah, let's check if this works. I want them to be equal, so I want them to so just see like binary goal and binary start. So let me check this. Yeah, looks like I had some troubles. Yeah, the trouble is here. So this should be goal. So yeah, now we have like leading spaces. So they're equal size. So if they're equal size, simplest thing which we can do, it's something like this. So we can have like a binary goal. We don't care much. No, actually we care. So binary start, we'll do chars, then we'll do a zip. So we'll do binary goal.chars, and then we'll do a filter. And here we'll have a tuple like goal and no, start and goal. And we'll do checks like how many s are equal or different. S equal g. So we'll need to count this and make it as an I32. So I think that should be it. Yeah, the first example works. Yeah, let's add a couple of other. So start 3, goal 4. And how many did they expect, like as well? 3. So both of them works. So we have like a working solution. The thing here, I'm thinking, how can I extract this repeating code? Where do we need to? Yeah, let me try to run it in on LeetCode first. Okay, so yeah. This will work. Yeah, probably I think we'll finish for the day. I'm up almost 2 hours. Yeah, so looks like it worked. Yes, so Bay, are you still in the chat? Because if you're still here, is that the solution which you kind of thought to have? Or is it a different one? So yeah, probably you're not in the chat anymore. Okay, guys, so we solved a couple of problems today, like 3 or 4, including like the medium one with the DP approach. So let's check our results. 96. So actually 2 problems only. Because I think I had like a 94 or something. So yeah, we solved 1 medium and only 2. That's a little bit. Yeah, looks like only 2 problems we solved. Felt like way more than that. Weird. I have a feeling like we solved more than that. Okay, so we solved this, this. Yeah, let's try another one. Congrats. Yeah, thank you. So yeah, I think that was exactly what you suggested, if I understood it correctly. So we transformed first number and second number into binary representation, and then count the pairs, exactly what's asked in the solution. Yeah, but I didn't get the stuff with the XOR, so unfortunately there are no other solutions in Rust category, so I couldn't see an XOR solution. Or wait a second, maybe there are. Oh, so look here. So we have flips, goal. We'll do start is not equal to goal. Okay, if start is 1, and flips +1, and we do an XOR operation. Yeah, one day I'll be good at this. One day I will understand what this even do. Because my stuff looks ugly. It works, but it's ugly. Yeah. Oh, this one is even cooler. Oh my god. So it does an XOR on the bits and counts how many are ones. Okay, so that's really insane. Yeah, but I don't get it, so that's the trouble. I need to understand the binary operations or binary math in order to use it consistently in my code. I don't use it enough at work because to be honest, I never had a problem where I needed to solve it using flips or work on binary stuff yet. Maybe in the future, but not for now. Okay. Yeah, should we look another one? Maybe I'll try to look another one. Okay, so largest local values in a matrix. So you're given an n by n integer matrix grid. Generate an integer matrix max local of size n minus 2 multiplied by n minus 2, or will be the size, such that max local of ij is equal to the largest value of the 3 by 3 matrix in grid, and centered around row I plus 1 and column j plus 1. What? Yeah, I feel like I don't have energy to do this one. So I'll probably will continue this during our next session. So yeah, thank you guys for joining in, watching it. So we'll do the next session, I guess, Tuesday. So yeah, have a nice evening, guys. So wish a nice evening and a nice day.